Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video, we are going to learn another question that was asked in the same 2023 December NET exam. So this is the molecule and the question is we have to identify whether this is aromatic, okay, or it is anti-aromatic, okay, non-aromatic or homoaromatic. That is the question. So let us first understand in general what are the different conditions for a compound to be aromatic. Which are the conditions? Okay, a molecule should be cyclic, that is it should be a closed ring structure. It should be planar, that is all the carbons must have sp2 hybridization so that they are trigonal planar. They have trigonal planar geometry and it will be planar. Okay, next is they have conjugation, for example like this. Conjugation means alternate double and single bond. Either it can be double bonds or it can be a carbocation, or another method is you can have an atom that has a vacant p orbital like boron or aluminium. Okay, so that this pi electrons can be donated in the vacant p orbital of these metals. So this is the meaning of having conjugation. Okay, then it should have 4n plus 2 pi electrons. Now what is n? N is any number. Okay, it can be 0, 1, 2, 3. Okay, substitute n is equal to 0, you will get 2. So it should have either 2 pi electrons or n is equal to 1, 4 ones are 4 plus 2, 6 pi electrons. Or if you substitute n is equal to 2, 4 2s are 8 plus 2, 10 electrons and so on. We had seen in the video of aromaticity, in what is a shortcut, you have to count the number of pi bonds. Okay, if there are odd number of pi bonds, then it is going to be aromatic. Similarly, what is the conditions for compound to be anti-aromatic or molecule to be anti-aromatic? Three conditions are same. It should be cyclic, it should be planar, it should have conjugation. Only one condition that is different is it should have 4n pi electrons to be anti-aromatic. Again, n is any number 0, 1, 2, 3. What was the shortcut for this? Okay, it should have even number of pi bonds. Even number of pi bonds. Okay, these shortcuts are helpful when there are multiple molecules. Here there is only one molecule, so we can count all the electrons. Last is, what is the meaning of a non-aromatic compound? When a compound will be non-planar. When a compound will be non-planar? When it has a sp3 hybridized carbon. Okay, because the geometry of that is tetrahedral. Okay, it will be non-planar. Okay, so it will not satisfy this planarity condition. So then it will be called as non-aromatic. Example is this. Okay, cyclopentadiene. You can see here, one hydrogen will be below the plane, one hydrogen will be above the plane, because this is going to be sp3 hybridized carbon. So this is an example of non-aromatic compound. So now let us see the molecule that is given to us. So here there are how many pi electrons? So let us first see whether it is cyclic. Yes, it is cyclic. There is no open chain structure. Is it planar? Let us check. Okay, this oxygen is sp2 hybridized, one lone pair plus 2 sigma bonds. Okay, steric number is 3. Then all these carbons that are forming pi bonds, they are what? They are sp2 hybridized. Nitrogen is also sp2 hybridized, one lone pair and 2 sigma bonds. Okay, this, and then boron. Boron, if you see, again it is forming 1, 2, 3 sigma bonds. So it is sp2 hybridized. So all of them are sp2 hybridized. So planarity is also maintained. So it is planar. Okay, then what we have to see, conjugation is present. Let us see. This lone pair, is it involved in resonance? No. Okay, this pi bond can shift here. This pi bond can shift here. Now in this oxygen, both the lone pairs are involved in conjugation? No, this is not involved. This will be involved. Okay, so this will move here like this. This pi bond will shift here. This pi bond. Now, is boron sp2 hybridized carbon? Yes. So there will be one vacant p orbital like this. Okay, we saw just now family of 13 group, that is boron family all the atoms have a vacant p orbital. So this pi electrons can be donated to the vacant p orbital of boron, and this can shift like this. So conjugation is also present. Okay, so now the next, okay, the last part is you have to count the total pi electrons. Okay, so 2, 4, 6, 8, 10 and 12. Okay, this lone pair is not involved, this lone pair is also not involved. So total how many electrons are present? 12 pi electrons. Okay, or if we look by shortcut, there are 6 pi bonds. Okay, that is even number of pi bonds. Correct. So this follows which rule? This follows 4n pi rule. Okay, if I put n is equal to 3, I will get 12 pi electrons. So this system is what? This system is going to be anti-aromatic. Okay, so what is the correct answer? The correct answer will be option 2. Okay, I hope you have understood the solution. Thank you.